Hi there, this is Jacob Nash Engineering Lessons, and this is Unit 1.3, Lesson 4 on Thermodynamics problems, and this is the third type about calculating R value. Now, if you just saw that video clip at the beginning, if I put it in there, I'm pretty sure I'm going to. I hope I'll be able to, but if I'm not, then there was a video, and I was in my attic, and you could see the insulation and the wall studs. You could see how that is, and that applies to this problem that we're about to solve. So, what is R value? Well, it's just it's a calculation based on. Well, it really we're trying to find the total R value. That's how you can add all the different R values of each of the different components of the wall that is here, and the PLTW provides a sheet of the R values of different materials in the wall. So what do we have here? So let's just say this is component 1, 1/2 inch drywall. So this is going to be inside, and then we have the wall, and then here's outside, because we have the shingles, that's outside. Then this is the loose fill rock wool, the insulation, and that's why I made it pink. Then there's 1 inch, and it says EP because I did not want to write that all out, but that is the extruded polystyrene. Then we have the wooden shingles, let's make that 4, and then a 2x4 construction, which is the wall stud, number 5. How do we calculate the wall cavity R value? Well, first of all, what is the wall cavity? You know, when you have a cavity in your tooth, there is like a hole in it. So where's there a hole in this wall? Pretty much, if you took out the insulation, there would be a hole right here. So we're gonna add all of the R values, because that's how you calculate the total R value. To do that, you add all of the components. And I know that looks like it could be resistance total, like from the last unit, but that just means R value total in this case. And component 1 plus component 2, and then etc. That's why there's 3 dots there. And so what are we going to add? Well, we don't want to count this stud because it's not part of the cavity, the wall cavity. So we're only going to add the R values of 1 through 4, not 5, for this first part. Now, you might be like, how do you calculate the R value? Well, it's not something you have to calculate. Like I said, it's on a sheet that says what each thing is. So, the R value of this, the drywall, is 0.45, and there is no units for R value. It's just a number. And then I'll actually do it in a different color for the rest. And then for the loose fill rock wool, it is 3.1 per inch. We'll talk about what that means. I'll just say this: 3.1 per inch. Then this 1 inch extruded polystyrene, the R value is 4 for it. For the wood shingles, it is 0.87, and then for the construction, it is 4.38. Now, back to this. We can't do anything until we can't just plug in 3.1. So it's per inch. And, oh, sorry, I forgot to write that on there. It is 3 inches of loose fill rock wool. So if it is, the R value is 3.1 per inch, then all we have to do is multiply 3.1 by 3. And that would give us 9.1. Or sorry, 9.3. Wrong color, don't know why. Didn't work on that. 9.3. So that's the R value of that. Now we just have to add, for this it's going to be including 1, 2, 3, 4, and 5. Or sorry, not and 5. And then this one, it's going to be included, it's going to include 1, 3, 4, and 5. We'll talk about why later. So we have to, all we have to do is add them. So for 1, we said that was 0.45. And then 2 is 9.3. And I'm not going to write it all out for sake of time, but you would add then you would add 4 and then 0.87. Once you add all of those, you get 14.62. But you would just have to add all those components that's written in blue. So no units once again. And then R value at the stud. So at the stud, this is the stud. And we don't count the insulation. So this is the insulation. I'll just say insul. But we don't count that for this one. So that's why that 2 isn't there. So this time we're gonna add anything I check in green. We're gonna add 0.45 plus 4 plus 0.87 plus 4.38. Then we get for the R value of that, 9.7. You should probably write out your work for like a purpose in your teacher's classroom, but I just didn't for sake of time. Now, a question might be, what R value is better for the house's like circulation, I guess. It would be at the wall cavity, because that's the point of the insulation. It makes the R value higher, which is better. And if you just had stud everywhere, then it would be a low R value. So that's why it's good to have insulation. And that would be it for this video. Thank you for watching, and we'll look at our final type of thermodynamics problem, which is on Stefan's law and finding the energy transfer using that. Now, that's a tricky one, so be prepared for that if you go on that. And it's probably going to be a long one as well. So thank you for watching, and I'll see you on the next video.